All right, chemistry, we're on to the second video, and we're going to deal with, in this video, empirical formulas. There's two types you'll be asked about on this. It's when you're given grams of each of the substances, and then the other one will be combustion reaction, okay? So we're going to write the molar mass of N and O using the periodic table. So down here, okay, and so we've taken care of this. Okay, compute the moles of nitrogen and oxygen. Again, anytime you're dealing with a chemical formula or equation, you've got to be in moles, okay? So it tells us we're given 24.5 grams of nitrogen. Again, label every time you do this or you're going to get them reversed sometimes, okay? Okay, and after we do this calculation here, we get 1.75 moles of nitrogen. 24.5 divided by 14. Over here, we got 70 divided by 16. We get 4.44 moles of oxygen. Okay, so we did that. Now we create the ratios. Okay, so N, we did the smallest one on the bottom. So 1.75 is smaller than 4.44. So again, label which one is which. And so the smaller one is always going to end up being a ratio of 1. Here. And if we do that, we get 2.5 and 1. Okay, so we have to have whole numbers, so we're going to have to multiply that by 2. So we're going to multiply that by 2, which equals 5. Now we're going to have to multiply that by 2 as well. Okay, and that equals 2. So now we have whole numbers, so now we can write the empirical formula is N2O5. Okay? And that's all there is to that, all right? Okay, empirical formula, problem. And it's a decomposition reaction. It's going to give you 3 elements, CH and O. So we got to go ahead and get the molar mass of carbon, hydrogen, and oxygen. So I'll just kind of speed through that. Okay, so there you go. Now we're going to go ahead. We need to convert to moles. Anytime you're dealing with a chemical reaction or a chemical equation, you must be in moles. So we're going to start and label each element. Otherwise, you can easily get them confused. So we're going to start with carbon. Okay, and we're given 60 grams. And I'll just go ahead and write the equations first and then do the calculations. Back on the screen here, and now we're going to go ahead and do the calculations. Okay, and for carbon, 60 divided by 12, we're close enough. We're going to call it 5, round it a little bit. 4.48 divided by 1.01, that's going to give us 4.44. And again, I should always write what they are. It's moles of carbon. And this one here is going to give us 2.22. Okay, so now we're going to go ahead and we're going to make ratios. Smallest one on the bottom. The smallest one here is 2.22. So first we'll start with carbon. Okay, the first one's going to give us 2.25. The second one is going to give us 2, and the third one is going to give us 1. Okay, so 2.25, I'll come over here and do this, is not a whole number, so we multiply by 2. Get 4.5, that's not a whole number, so we go to the next whole number, 2.25 times 3. 6.75, still not a whole number. 2.25 times 4, and that's going to give us 9. That's a whole number, okay? So we're going to do 9, and then down here we have to still multiply by 4. So it's 2 times 4 equals 8. And then here we have 1 times 4 equals 4. Okay, so our subscripts are going to be 9, 8, and 4. Be sure you keep straight which is which. So carbon is going to be 9. Hydrogen is going to be 8. And oxygen is going to be 4. Okay, and that's the empirical formula. Okay, so the next problem, we're doing a combustion reaction for empirical formula. So we went in the lab, we combusted some unknown hydrocarbon, and we came out with some number of grams of carbon dioxide, 33.01, and some number of grams of water, 13.51. So we're going to go ahead and write the flow chart, and you will be given the flow chart on the test. So I'm going to go ahead and fill in down here in the grams row. Alright, there you have that. So we write the number of grams in the appropriate boxes above using the molar mass of CO2. So I'm going to fast forward you through that one here. So you know how to compute this. Okay, there we go. Alright, so now we've got to convert using the two conversion problem, right? A two conversion problem. So we need to go from grams of carbon dioxide to moles of carbon dioxide, but you don't actually do that calculation. It's a two-step problem. And then once you have moles of carbon dioxide, you need to get to moles of carbon. So write the coefficients of 1 here and a subscript of 1. That emphasizes that for every mole of carbon dioxide, you get 1 mole of carbon. And over here, you're going to convert from grams of water to moles of water, and then from moles of water to moles of hydrogen, because that's what we're interested in finding out. So go ahead and write this coefficient here. So for every 1 mole of water, we get 2 moles of hydrogen. Okay, so we're going to go ahead now and write that out. So first for carbon, okay, so now we've gotten to moles of carbon dioxide. Now we need to know moles of carbon. That's what we're interested in. And we saw on the flow chart it's 1 to 1. Okay, and we do the math on that. All right, and this gives you 0.75 moles of carbon. Okay, next we go down to hydrogen. Okay, and again with hydrogen we have 2 moles of hydrogen for every 1 mole of H2O. So we just calculated moles of H2O, and we're going to get 2 for 1 with the hydrogen. Okay, and that gives us 1.5 moles of hydrogen. Okay, 1.5.75. Now we're ready to go to the ratio. So again, label everything. Okay, the least number is the 0.75 for carbon. And remember, the least number is always going to end up to be a ratio of 1. Okay, so we ended up with 2 whole numbers. So the empirical formula is going to be C1H2, or you just write it CH2 is the empirical form. Okay, all right. Now we're ready to go on to the next step and figure out what's the... Okay, so CH2 is the empirical formula. Okay, so we got 0.75 moles of carbon is what we got up here, and 1.5 moles of hydrogen, and all the carbon here, 0.75 moles of carbon, and that comes from here. That's the only place it could have come from. It's the only place you have carbon. All the hydrogen had to come from here, 1.5. Okay, and then we created our two ratios. Okay, so that's how the flow chart walks you through the problem. All right, so we got CH2. Now, we need one more piece of information to find the actual molecular formula, and that piece of information is up here, and it's 28.06 grams is the actual mass, molar mass of this unknown gas. How you got to know that number, you don't need to worry about it this time. Just accept that you have that number, okay? So now we're going to come down here, and we're going to write molar mass. That's the actual molar mass. And now we have to figure out the molar mass of the empirical formula. So we come over here, it's CH2, so it's going to be C is 1 times 12.01. H is 2 times 1.01. Okay. And when you add those two together, the molar mass of the empirical formula is 14.03 grams per mole. Okay. Now you have to get the scaling factor or the multiplying factor, and it's going to be the molar mass, the actual molar mass over the empirical molar mass. Okay, so that's going to be the number we had up here is 26.06. The empirical molar mass we just calculated is 14.03. And do the math, and you get a scaling factor of 2. So now you take the empirical formula, you come down here, the C is a 1 times the scaling factor 2. H is 2 times the scaling factor 2. And that gives you an actual molecular formula of C2H4. And that's your final answer. Okay. Okay, now we're on to the last problem. It's going to be done exactly the same way as the previous problem. Okay, and you have the answer there to check yourself. So we're going to start off with this. Grams of carbon dioxide, and this for water, H2O. Okay, so there we have our conversion factors there. And we know also that up here, as we did last time, 1 mole of carbon gives you carbon dioxide gives you 1 mole of carbon. 1 mole of H2O gives you 2 moles of hydrogen. Okay, so we're just going to go ahead and I'll kind of speed through the equations here. So first for carbon. Okay. I'll go ahead and write the equation for hydrogen. And now up here we have 2 moles of hydrogen for every 1 mole of H2O, so we need that conversion. Alright, and now we'll do the calculation. Okay, and after doing the calculation, we get 0.13 moles of carbon, 0.13 moles of hydrogen, so we're going to write those up here. There's carbon, there's hydrogen. All the carbon that you see on the product side is in the carbon dioxide, and it could only have come from one place, from this. So that means this is 0.13 moles. Okay, same with the H2O, 0.13. That means it only could have come from here. Okay, so there we go. So now we're going to go down and we're going to continue with the problem. So the ratio is going to be for carbon. It's going to be 0.131. Okay, so it's 1. Those are whole numbers. So that means the empirical formula has to be C1H1, or we just call it CH. So that's the empirical formula. Okay, there you go. Now we're going to go on, and we're given a molar mass right here of the actual substance, the actual gas, 78.11 grams. Equals 78.11 grams of whatever this substance is. Okay, the empirical molar mass, let me write that down here, mm molar mass. Okay, you got a C and an H, so it's C is 12.01, you just multiply that by 1. H is 1.01, you multiply that by 1, and you end up with, I'll just write it here, 13.02 grams. Okay, So now the scaling factor, N, is going to equal the actual molar mass over the empirical molar mass. Okay, and that's approximately equal to, it really is equal to 6. So that's your scaling factor, N. So you take C1 times 6, H1, your empirical formula, times 6, and you get up C6H6, and that's your final answer. That's your final molecular formula. Okay, that wraps up this video, and I hope it helps you to do better on the quiz.